Hey, how you doing, guys? It's Ilya Belly here. I record and stuff on YouTube. Check the description for all my information. I do all LeetCode problems. Make sure you subscribe to the channel. Give me a big thumbs up to support it. And add and search word data structure design. Design a data structure that supports the following operations. Add word and search. Search word can search a literal word or a regular expression string containing only letters A through Z, or .a. Dot means it can represent any one letter. Well, like bad, dead, mad. Bad, false. Bad corresponds to bad. Add corresponds to any of these words, and b corresponds to bad. You may assume that all words are consist of lowercase letters A through Z. That means like 26 letters. You already know about that. And there is a funny data structure. It's called tries, or just prefix trees. That means that uh, each node represents a letter or just character, whatever, and all nodes can form a word, and to mark this word, like each path down the tree represents a word, and to mark this word like a final, complete, you need to create an extra node like star, or just create a variable like boolean and something like is word, or just and set it to true, like something like it is a complete word. So you just need to know about that as well. Well, go ahead, let's start. I'll show you how to do that. First off, you implement a data structure. You say class tries node tries just try node array of children, and then to mark this as a complete word, you say boolean is word. Then you create constructor. You say public try node, and here you say children equals to new try node 26, because like 26 letters in English alphabet, right? Then you need to create a private try node root, and initialize your data structure. So you say like root equals to new try node. You need to implement add word. Well, you say it's a word into the data structure. You say try node current node, like root, and then for loop. Character C and word to character array, and you need to create index first. So you say int, I already explained it. I already explained about the ASCII table. As you know, guys, in Java there is an ASCII table, and each character can be represented in binary form, or just in decimal form, or just hexadecimal form. So to do that in Java with integer, you say C minus A, and then try node current root word to character array, and you check if current dot children C minus A equals to null. That means there is no letter. I mean, there is no node which represents a letter in that tree. You need to create a new one. So you say current children C minus A equals to new try node, and at each loop you say like current equals to current children C minus A. Yes. Why we do that? Because we wanna move to the next node. Suppose we got like A, B, then C, and to get from A to B, you need to say current the children and C minus A, and each node in that tree can contain up to 26 letters, 26 characters. So at the end of this loop you say current to mark this node as the end of the word. So like something like this is a complete word. So you say current is word equals to true. It was false by default, and now it's true. And yeah, that's it. Then you create a search. You say if word equals to you say you need to create an extra method, a helper method. It's called find, and here you pass word, then root and 0 index, and now you say private boolean string word try node root and index. You check if index equals to the length of that word dot, and we return this node dot is word, and yeah, and then that means it is complete or not. Then you say character c word dot character at index, and if c equals to dot, like here, in this case you create a for loop int I equals to 0, I is less than 26 letters, I plus plus. You check if root dot children at I doesn't equal to null, and private boolean find, and find word root dot children at I, and index plus 1 because we wanna move to the next, we wanna handle the next letter. Then we go here to the next, like from left to right. If it's so, we return true, otherwise we return false. Return false. And else, if and else, if it's not dot, in this case we need to return find, find, but before we also need to check if root dot children, again c minus a doesn't equal to null, and find word root dot children c minus a and index plus 1 to move to the next letter. I'll explain it to you one more time. So we just create our data structure try node. It contains the array of children, is word to mark this word like it's complete word, whether it's complete node or not. It's complete word or not, and we initialize this array like children, new try node, the length of that array will be 26 because 26 letters. We create try node root and word dictionary, initialize your data structure, root, new try node. After that, you need to implement add word method. You say current equals to root, then we are looping through these characters in this word to character array. Index c minus a, you know, like here if it's null, then we, if there is no node in that tree, we create a new one. After that we set up a new value to current children, and at the end of this loop we say is word equals to true. This is a complete word. Then to implement, we need to create a helper method. It's called find. We pass word, root, and 0. Private boolean find string word, root, and index. If index equals to word length, that means that we just just get to the end of this path. So we say return root is word. If it's complete word, in this case we return true. Otherwise we return false, or just otherwise we just continue. We just keep on going looping, like not looping, like call this this method recursively. So if c like here equals to dot, we are looping through all characters in English alphabet, all letters, lowercase letters, and we check if it doesn't equal to null, and the no doesn't equal to null, and if it's true then we return true. Here index +1 to move to the next letter. Otherwise we return false, else return if it's not dot, then you again like check again and again, like you just go on, that's it. Let's run this code. There we go. I think that works. Nice, good. Thank you guys for watching. Leave your comments below. I wanna know what you think. Subscribe to my channel, subscribe to my Instagram, Snapchat, add me on Snapchat as well. There is a link in my bio, check the description for all my information, and see you next time. Thank you. Bye.